There is a moment that happens before every major, severe weather outbreak. A quiet moment. A moment that most people never see and never know about. It does not happen when the sirens are wailing. It does not happen when the radar is lighting up red and the news anchors are cutting into programming with breaking alerts. It happens days earlier. It happens in the hours when forecasters are sitting alone in front of computer model data, scrolling through atmospheric projections, and something in what they are seeing makes them stop, makes them look again, makes them lean forward in their chair because what the atmosphere is showing them is not ordinary. It is not routine. It is a pattern they have seen before, a pattern with a history, a pattern that, when it assembles itself fully with the right ingredients stacked in the right configuration, does not just produce bad weather. It produces the kind of weather that changes communities, the kind of weather that ends lives, the kind of weather that leaves marks on the historical record that persist for generations. That moment is happening right now, and what the atmosphere is building deserves your full and undivided attention. Here is what you need to understand before anything else. Not all storms are created equal. The difference between an ordinary summer thunderstorm rolling through your area, dropping some rain and maybe some small hail, and a violent, long-track tornado capable of wiping entire neighborhoods off the map is not just a difference of intensity. It is a difference of atmospheric architecture. The atmosphere has to build a very specific structure, layer by layer, ingredient by ingredient, before it becomes capable of producing the kind of severe weather that forecasters genuinely lose sleep over. And right now, the atmosphere is doing exactly that kind of construction work. It is assembling every ingredient that the most dangerous outbreak days in the historical record have in common. And it is assembling them across a broad region of the country at the same time. So let me walk you through exactly what those ingredients are. Because understanding what is coming is not just about knowing that storms are on the way. It is about understanding why this particular setup is so serious, why experienced forecasters are not treating this as routine, why this is the kind of event that demands your attention not when the storms are already overhead, but right now, days before they arrive, when there is still time to prepare. The first ingredient is instability. Think of instability as the fuel, the raw energy that powers thunderstorm development. Meteorologists measure it using something called convective available potential energy, CAPE. On an ordinary afternoon across the southern plains, you might see CAPE values sitting somewhere between 1,000 and 2,000 joules per kilogram. That is enough to support strong thunderstorms. On a significant severe weather day, a day that gets people talking, a day that produces widespread damage, CAPE values push above 3,000 joules per kilogram. And on the kind of day that gets written into the climatological record, the kind of day that researchers and forecasters still study years later, the kind of day that appears in training materials used to teach the next generation of meteorologists, CAPE values can approach or even exceed 4,000 joules per kilogram. The values currently being projected by the models for the highest risk period of this coming event are not in the ordinary range. They are in the range that commands serious attention. They are in the range that tells you the atmosphere is not in an ordinary mood. But here is the critical thing to understand about instability. By itself, even extreme instability does not produce the most dangerous severe weather. You can have enormous CAPE values and end up with nothing more than a disorganized mess of heavy rain and lightning and occasional hail. What separates a bad thunderstorm day from a major tornado outbreak is the second ingredient. And this is where the current setup becomes genuinely alarming. Wind shear. The change in wind speed and direction with height through the atmosphere. When surface winds are flowing out of the south or southeast, pulling warm and deeply humid air northward from the Gulf of Mexico, while winds at the mid-levels of the atmosphere are veering to become southwesterly, and winds at the jet stream level are roaring out of the west or northwest at very high speeds, the atmosphere develops a quality that meteorologists call rotation. Not the rotation of an individual. Storm, the rotation of the atmospheric environment itself. A background spin that individual thunderstorm updrafts can tap into and amplify. When a storm updraft tilts that horizontal spin into the vertical, wrapping it up into a rotating column of air called a mesocyclone, you have the engine of a supercell thunderstorm, the direct precursor to a tornado. The wind shear values currently being projected for the most dangerous period of this event are not marginal. They are in the upper tier of what the historical record shows for major outbreak days. The directional shear, the veering of winds from southeasterly at the surface to southwesterly at the mid-levels, is particularly pronounced. And that specific configuration is precisely what maximizes the potential for long, persistent mesocyclones, the kind of rotating updrafts that do not spin up a brief, weak tornado and then fall apart, the kind that sustain themselves over long distances, the kind that produce long-track tornadoes, the ones that stay on the ground for 30, 50, even 100 miles or more, the ones that appear in the record books alongside dates that communities never forget. The third ingredient is moisture. And the moisture return being projected ahead of this event is exceptional. The Gulf of Mexico is not just a source of warmth, it is a source of deeply humid air, and the difference between warm air and warm, humid air matters enormously in a severe weather setup. The measure forecasters watch most closely is the dew point temperature, the measure of how much water vapor is actually present in the surface air mass. When surface dew points climb into the upper 60s and low 70s Fahrenheit across a broad region, you are dealing with an air mass that is carrying an extraordinary amount of latent energy. Energy that does not just sit there passively, energy that gets released explosively when convection fires. The moisture being projected to surge northward ahead of this approaching system is of exactly this character. Widespread dew points in the range that forecasters associate with the most energetic severe weather environments the central and southern United States ever experiences. That is not a casual observation. That is a red flag of the highest order. And then there is the fourth ingredient, the one that brings all the others together and actually pulls the trigger. The forcing mechanism, a powerful upper-level trough, digging southward out of the northwest. This is the dynamic engine that will initiate convection and allow the atmosphere to actually release all of the energy it has been quietly storing. A strong upper-level trough drives powerful divergence in the upper atmosphere. It forces air upward through the troposphere, acting as a trigger that fires thunderstorms even in areas where surface boundaries might not be sharp enough to initiate storms on their own. But when a powerful upper-level trough does not just interact with a quiet atmosphere, when it slams into a sharp surface boundary, a dry line or a cold front pushing into an extremely unstable, deeply moist air mass, the result can be explosive storm initiation across a broad area in a very short period of time. Not one or two storms slowly evolving over the course of a long afternoon. Dozens of storms firing simultaneously across a wide corridor, each competing for the available instability, some surviving, some growing into supercells. The ones that do survive finding themselves in an atmospheric environment that is practically designed to sustain them indefinitely. This is the scenario the models are depicting for the highest risk period of the coming event, all four ingredients, present simultaneously, at magnitudes that do not represent an ordinary severe weather day. And when experienced forecasters look at model output that shows this kind of alignment, they do not minimize it. They do not hedge it into irrelevance with qualifications and caveats. They begin the process of communicating urgency clearly and early, because there is one resource in a tornado threat that is more valuable than any other, and that resource is time. The minutes between a tornado warning being issued and a tornado arriving at a specific location are the minutes that determine outcomes. They are the minutes in which someone in the path makes the decision to take shelter or does not, to move to an interior room on the lowest floor or does not, to get away from windows and exterior walls or does not. Every additional minute of warning time that better forecasting and earlier public communication can provide translates directly into human outcomes on the ground. But individual warning lead time depends on something bigger. It depends on event lead time. The days of advance notice that allow communities to prepare before any storm has even fired. The days that allow emergency managers to preposition resources. That allow hospitals to review their mass casualty protocols. That allow school districts to make decisions about early dismissal before the most dangerous afternoon window arrives. That allow individual families to sit down together and talk through their shelter plan, to make sure that plan is solid, to make sure everyone in the house knows exactly where to go and exactly what to do if a warning sounds in the middle of the night when the whole household is asleep. That conversation cannot happen if people are not paying attention until the storms are already overhead. The preparation cannot be done in the minutes after the sirens start. It has to be done now, in the days before the event, while there is still time. And here is the part of this forecast that I want you to sit with for a moment, because it speaks directly to how seriously anyone in the risk corridor needs to be taking this. The current setup is one in which the upper end of what the atmosphere can theoretically produce is very high. The history of significant tornado outbreaks in the United States is a catalog of days when the atmosphere performed at or above the level the available data suggested it might. The great outbreak days, the ones still studied in meteorology. Programs today were not surprises in terms of the atmospheric setup. The ingredients were there. The signals were present. What sometimes surprised even experienced forecasters was the degree to which the atmosphere fully exploited every available advantage, producing storms that reached the absolute upper limit of what the environment could theoretically support, producing tornadoes that were stronger, wider, longer tracked, and more destructive than the median model outcome suggested. The current setup is one where that upper end is very high. The envelope of possible outcomes includes scenarios that are more demand, and the physics of this setup support the possibility of an event that exceeds what any single model run is currently showing. Arrive during daylight hours. Some of the deadliest tornado events in the historical record have occurred at night, when people has no idea what is happening outside. When the visual cues that experienced storm watchers rely on to identify threatening conditions, the rotation visible in a lowering cloud base, the greenish tint to the sky, the sudden stillness before a violent storm, are completely invisible in the darkness. The timing of the current event includes the potential for significant severe weather during overnight hours across portions of the risk area. That is a factor that cannot be ignored and cannot be waved away. What does it mean practically? It means wireless emergency alerts on your mobile to where you sleep to actually wake you. And it means understanding that even a fully functional smartphone alert system has limitations. If your phone is silenced, if your alert settings have been modified at any point, if your phone is charging across the room on a nightstand you cannot hear from your bedroom, you may not receive the warning in time to act. A weather radio with battery backup and an alarm set to activate for tornado warnings is the most reliable, accidentally modified. It wakes you up. And being awake is the first and most critical step in surviving a nighttime tornado. Shelter is the second piece of preparation that needs to be addressed directly and honestly. Not all shelter is equal. Interior rooms on the lowest floor of a sturdy structure, away from windows and away from exterior walls, that is the baseline. A bathroom with interior walls on the lowest floor, a closet in the center of the house, a basement when one is available. A basement is the single best shelter option in most residential structures because it places as much distance and mass as possible between you and the rotating winds above. If you have a basement, know exactly how you're getting there in the dark, because if a warning sounds at 2 a.m, the last thing you want to be doing is searching for a flashlight and trying to remember where the basement door is. And if you live in a mobile home, I need to be direct with you about this. Mobile homes are not safe shelter in a tornado threat. The research on this is not ambiguous. It has not been ambiguous for decades. No anchoring system, no tie-down straps, no specially designed foundation system makes a mobile home safe shelter from a significant tornado. If you live in a mobile home in the risk corridor for this event, you need to identify a nearby sturdy structure before the storms arrive, not when they are already on top of you. Because once the storms are firing, moving from a mobile home to a safe shelter may not be possible safely. The time to make that plan is right now. The geographic corridor that the models are currently highlighting as the highest risk area for this event is broad. It spans multiple. Atmospheric setup is not symmetric. The possible outcomes include scenarios significantly worse than the current model consensus. Deciding to prepare. Certainty does not arrive until the storms are already on radar. And by then, the time for preparation has passed. The time to prepare is now. The time to have, eat now. The time to identify your shelter location and make sure you can reach it quickly in the dark is now. The time to talk to your neighbors, the ones who may not be following the forecast as closely as you are, the ones who may not know what is building, is now. The atmosphere is not waiting. It is organizing itself on its own schedule, following physics that do not negotiate and do not respond to appeals for more time. When this event arrives, and it will arrive, the only thing that will matter is whether the people in its path were ready or were not. That decision is being made right now, in the days before the storms fire, not in the minutes after the warnings are issued. A major severe weather threat is coming. The ingredients are in place, the signals are present, the models are in agreement on the broad structure of what is coming in a way available, so that you and everyone you care about can stay one step ahead of what is coming.